Hello everybody. Let's continue discovering Oracle SQL queries. To select rows for which the value is not defined, meaning the row contains a null value, we should use a condition is null. Let's run this query, and as a result, we see one row with manager ID is null. To select rows for which the value is defined, we use a condition is not null. Run this query and we see all employees for whom manager ID is defined. Oracle has a special function that concatenates two strings. This function is concat. Let's look at this example. Let's take two strings, first name and last name. After executing this query, we see each employee's full name as one word. Obviously, is not what we would need. To make this field more readable, we should add a space between the first name and last name. But this means we need to concatenate three string values. To do this, we should apply the concat function 2 times or use the concatenation operator as shown in the next two examples. In the first example, you can see how to apply the concat function for concatenation three strings. To specify the name of the column with combined data, use as keyword. Run this query and we see a full name for each employee as first name, space, and last name. In the second example, we will do the same, but we will use the concatenation operator. As you can see, it's easy to use the concatenation operator for more than two strings. Run this query and we will see the same result as the previous query. Additionally, I'd like to demonstrate how some of Oracle aggregate functions work. There are, for example, functions that calculate sum, average, minimum, and maximum values for a certain group of rows. We can apply group functions to all rows of the table, as in this query, where we calculate the sum of the salaries of all employees in a company. But more often, we apply these functions to some group of rows and not to the entire table. To divide these rows into groups, we should use group by clause. Let's see the next example, where we group all employees by job ID using group by clause and then calculate the max, min, and average salary for each job ID. Also, let's sort the result by max salary in descending order. As a result, we see data for each job ID. Also, we can use some aggregate functions not only for numeric data. For example, min and max can be used for dates and character data. So let's use the min aggregate function to find the earliest employee hire date for each department. The next aggregate function is count. It returns the number of values for a group. We run this query, and as a result, we have data containing manager ID and the number of employees for each manager. We can use aggregate function count against any type of data. Sometimes we need to find only unique values. In this case, we should use the distinct clause together with the aggregate function. Let's run this query and see the difference in the data counting with and without the distinct clause. As a result, we have 108 rows where job ID is not null and just 19 unique job ID values. As we showed earlier, group by clause returns groups. If we need to filter groups, we will use having clause. For example, we need to take a list of departments with a minimal salary less than 6,000. In this case, after grouping employees by departments, we use having clause to apply this condition. As a result, we have only 4 departments that correspond to our requests. That's all for today. Thank you for your time.